We're going to talk about slaying software zombies. So, because we're registered with the SEC, Optimal Investments is, here are some disclaimers. I'm not giving you financial advice. Alrighty, so the conceit of this whole talk is that metacode, so the things that are associated with your code, like docs, tests, configs, requirements, etc., are organic the same way that code is. They grow, they rot if they're left unattended, right? They have another function to them that make them, I think, even more challenging. Whereas if you go the agile methodology route and you say the best requirements are a working piece of software, you don't really have the same sort of thing with the metacode. So you can get to a situation where things represent parts of the truth that are in various different parts of the metacode or the artifacts in the metacode, right? So like a ticket, for example, may describe a system that was accurately described 2 years ago, but doesn't describe what it is now, but it's still lingering around. So it can be difficult to figure out what really is. I think this gets especially tough if you iterate a bunch, as you're supposed to in Agile. Don't worry, if you are a proponent of waterfall, you get the same boat because your software doesn't wind up looking anything like the stuff that you spec'd out in the beginning. So there's no real win there, right? The other, I think, interesting observation is that it seems like metacode grows exponentially. It seems like to me, along with the code base, particularly as companies mature. You've got more communications overhead, more need to do things like document things or run a process. So as a result, you really see this acceleration to what I term the zombie apocalypse, where you've got all of these partial truths that are sitting out around here, and you can reach a sepsis point at which the whole system collapses. So what could this look like practically? Maybe you've had one of these cases where you overwrite a config that with the stuff that's in your IAC repo, and you wind up having an outage because someone did something on the fly, or you wind up having automated test suites balloon around testing functionality that no longer exists or no longer is valid. Similarly, you can do this when you're patching vulns on projects that you may not need the functionality from, or where people can't stand up a service because it was documented incorrectly. I know that's super frustrating for new hires. So, getting to the core of what I am suggesting, at some level, there is sort of an underlying platonic truth, a description of what the system ought to be doing or is expected to be doing, that lies at the center of all of the metacode and the code itself. So, tap into that, allow that platonic description as it changes to propagate those changes throughout this larger behavior graph. And I use the term controller, where you can think about it kind of like a control loop. So as you're iterating, whether you're doing this in an automated or manual sense, you're going to continuously update those pieces. All right. So if you've heard this kind of behavior graph or the abstraction I'm describing, it may sound really familiar if you remember BDD and the Cucumber era of, say, 2010, I think, roughly. So BD using examples at multiple levels of the system to create a shared understanding, and using that also as a bludgeon to try to surface uncertainty around how the system ought to behave. And we'll get back to BDD in a second. But the point being, this is not a new thing, right? Another diagram I feed from the internet, pointing out that examples, tests, and requirements are all interrelated. And they all kind of change and morph again. You can imagine, again, propagating, let's say you have a new example that covers something you didn't have. Well, that propagates through to your tests and your requirements. I'd also include things like user-facing documentation and also other things that are searchable like PRs and tickets. Tickets are particularly interesting because they're usually showing a defect in implementation or a system not behaving the way that you would expect it to. So you can kind of through implication figure out what the system behavior actually is supposed to be. And I did want to show this. Kubernetes has a beautiful operator pattern where it uses controllers in order to control the drift of all these different interrelated pieces of code. So at some level, we already do have a structure that we can use to control drift that we can tap into. All right, so practically, how do we fight these zombies? I'll show you sort of 3 sections of this, and hopefully they'll be useful. The first is paring down your metacode. All right, so I think like with everything else, this is definitely one of these 80-20 rules. Think about where the metacode that you have is best utilized. Oftentimes people think about this in terms of testing. I think that's that's one of the pieces of metacode, so it's a useful way to step into it. But you can think about it in terms of the documentation or whatever else that goes with it. So I always think about, hey, where am I trying to build trust with users? Because I work on a commercial product. This might be different. Your mileage may vary, but we'll use that. So where you have user-facing documentation, including how you go through a workflow, or if you have a library, you're providing examples for it. Hey, those are pretty good places to make sure that, you know, if you're telling to the world this thing works this way, that it actually does work this way. Another place, startup steps. If you're onboarding a new user and it doesn't work the way that they expect, or you have a new developer that, you know, can't get a service started up, I mean, those are places where people are already somewhat tenuous. Definitely, I think, worth typically investing the extra time. And then a couple areas, we'll talk a little bit more in the context of this I think, interesting book and article. Areas that are prone to change, you know, places that are complex or really matter, and also areas that don't change much at all. And this book is called Your Code is a Crime Scene. And a lot of it is trying to, the author describes, you know, intuition not scaling, and then the complexity measures that they use not working well enough. So having to have some other set of heuristics or tools to identify places where, you know, you'd want to put your next incremental test. And I think, you know, he lists out these three ideas or questions rather that should be answered. I think really interesting points out that there are two good predictors of bugs. One is the number of developers working on a module, and the other is the number of revisions. And I add a third one to that, which is areas where neither of those things are true. Those are areas where I think you definitely want to test or document. You get into those sort of bus number problems, you know, where someone has never touched this piece of code or the system, and then it falls over, and you have no idea how to get yourself back out. So I'd add to that a little bit. So he's got this cool tool. I don't recall it working the last time I tried it, but, you know, that was a long time ago. But anyway, assume that you did. You get this really cool graph. I believe these are modules, and the individual items in there are methods. The height of the graph being the number of changes that happen, and the color being the number of authors. So visually, you can see within this code base where the next place you likely would want to put tests. Or, you know, by extension, documentation or examples. All right, let's talk LLMs. I think of LLMs as being translation machines, or like really enthusiastic and experienced interns. So what does this matter in the slaying of zombies? Well, you can use an LLM to better help you update items across this behavior graph. It's very useful for that sort of translation piece, because again, you know, it's like that old adage about the elephant. People touch different parts of the elephant. Those are the different pieces of metacode that are coming together holistically to form your description of the system. So here's a practical example. At Opto, we had a whole bunch of playwright tests, which are in browser tests like Selenium or Cypress. And I found this, you know, this repository when someone left of, you know, dozens and dozens of these, say, 700 to 900 line long TypeScript browser tests. And I discovered them because they were flaking out and were slow, and were causing all sorts of problems. So here's an example, real example of this test to check whether a loading state was being brought up when something was loaded. You know, they're spinning up a whole browser and spinning it back down to do this. It was failing 10 times a day on average, and that resulted in 300 minutes of developers waiting around for something that wound up failing and having to rerun it. So I thought that was kind of ridiculous. So I wanted to look holistically at, like, hey, are these tests worth the effort? And also, what kind of coverage do you have with these tests, which is actually a lot harder to do with these browser-based tests than, you know, if you were using a Jest or a PyTest or something like that. So I wrote this. I thought this was kind of a cool way of approaching it. I iterated the test files and then sent them to a GPT model with this prompt here, but basically saying, hey, can you describe to me the feature that you're testing, right? You iterate through. I dumped the description out to Markdown. I served it up with stuff that I also had ChatGPT write. And of course, I used Midjourney to make a cool image. Irulan, who is the biographer of Paul Muad'Dib for you Dune fans, and it produces this thing here where I've had to excise a whole bunch of the names of tests, but you get the gist, right? And here's an example of the workflow that it's able to develop. And I found this to be really useful, right? This is now translated into a language that I could use to assess what's actually going on in the workflow that's being tested, and kind of compare that to the workflows that I see actual people using. In this case, yes, certainly. You can extrapolate to all other things about how you would break these tests down into integration or unit tests, or data table tests, or where we should have been testing on the API level. But it was very interesting to go across the code base and realize, like, hey, places where, for example, it said we were testing such and such a dashboard, the test only made sure that the page loaded, right, or loaded without error. And other places that had this, this very significant description of an actual workflow that a user might do. And that got me thinking about living documentation. That's where we're going to turn to BDD. So here's that tweet again, BDD in a tweet. So basically specification by example that's also testable. And part of the core here was this idea that you could use the language of the business domain so you can engage with business users in terms of writing a test and building or writing tests that verified that you had built a system that met with their expectations about what it did. And it was really cool a while back to find, hey, living documentation really is a thing. Here's an example with Concordian. You can see how it's set up. The examples here, they get translated into Cucumber tests, and they're sparsed within within the documentation of the product. So what's challenging with this, and why, as cool as I think that this is, to have your documentation generate your tests, it's going to generate your tests that are heavily reliant on regex. There's that old adage that if you solve a problem with regex, you have two problems. It got pretty messy and unwieldy, when I've seen Cucumber suites grow. So what is cool, I think, to kick around is this idea that you can use an LLM rather than a regex to do some of this updating. So here's an example covering the prior one of GPT models producing a data table test in the Python version of Cucumber, Behave, that uses the underlying large language model instead of regex to do that matching for you. So you can imagine a system like this where you're like propagating changes in the system behavior automatically through to generate the tests, or as I showed you, from the tests to propagate back through to generate the living documentation. You can imagine a whole bunch of other methodologies using LLMs and knowledge bases to try to create like a more holistic view of that sort of behavior graph that I was describing and make this all better. Okay, so much of the work wasn't mine. Well, most of it was whatever it is. Lots of people helped me. It was awesome. I'm tongue-tied. These Optonauts are fantastic. And here's where you can email me, pk@optoinvest.com, and some AI-generated Pythons because they're cool. Alrighty, thank you so much for your time. Look forward to seeing you all in person when this isn't virtual in Ohio. Cheers.